I am Anil Kumar. Welcome to your YouTube channel. Here you'll find solutions to your request. Keep sharing and keep learning. Here's a beautiful question based on Pythagorean theorem. Now there are some integers whose sum of squares is equal to square of an integer, and these numbers are called Pythagorean triples. Example is given to you right here. And the idea of this particular question is to derive a formula to get Pythagorean triples. So, first part of the question is complete the following with a perfect square as shown in the first example. So, 3 square plus 4 square is 5 square, very well known, simplest form of triangle with Pythagorean triple. You can definitely verify this. 3 square, is 9, right? Plus 4 square is 16, and 5 square is 25, right? And 9 plus 16 is indeed 25. So it works, right? Now the next one here is 5 square plus 12 square is equal to what? So 5 square, is 25, and 12 square is 144. And when you add them, you get 169, which is 13 square. So in this case, we get 13 square here. Now, if you carefully look at the pattern, what do you notice? That is what is important at this stage. And once you notice the kind of pattern we are getting here, you will be in a position to develop a relation. So, the whole idea is to actually build your thinking capabilities to derive new things. That is one of the key rules which our students are working for. So the next one is 7 square plus 24 square equals to what? So as per the pattern, I could easily see that 5 is 1 more than 4, 13 is 1 more than 12, and therefore for 24, I expect 25 square. Well, you can always verify this, and if you do so, 7 square, is 49. You can use calculator, right? So no issues. You can use calculator. You got 24 squares equals to 576 is equal to what? When you add them, you get what? Plus 49 to 24 square, you get 625, right? And 625 is 25 square. Otherwise, you can square root and figure it out. So once again, what we confirm right here is that these Pythagorean triples have some kind of a relation, right? And definitely in this particular pattern, we see that the numbers are related, right? So, so the number here plus something equals to the number here. If whatever the number is out here, this is one more than that number. So that kind of pattern you will actually see. That is one thing which can help you get the formula. Now, to derive a very general formula, we are going to use a different strategy. The strategy here is, after all, what is a plus b whole square, right? So let's look into that. So we'll now explore. Let's say we have x plus y, right? So x plus y whole square is equal to what? Well, x square plus y square plus 2xy, right? Normally we write 2xy in the middle, but I kind of change their position. Right? Similarly, x minus y whole square is actually x square plus y square minus 2xy. Now, if I say that x plus y is one side of the triangle and x minus y is the other side of the triangle, in that case, I think we can get the third side, and therefore we can also derive the formula. After all, we are working for a Pythagorean triple. You get the idea, right? You can pause the video at this stage, try it out, and then check with my solution. From here, you do get a hint of how do we find the formula. So on a fresh page, let's work out. So we're looking for something which could give us a right triangle. So let me just sketch the right triangle for you here. And in this right triangle, we're looking for the three sides. Now imagine that instead of writing x plus y whole square and x minus y whole square, let us say that the sides for us are x square plus y square, and the other side is x square minus y square. In that case, what could be the third side? So let's work this out. Now, definitely, what we have here is that we don't know this side. So we'll say that this side square plus square of x square minus y square equals to, the square of this is square of x square plus y square whole square. So that means that this unknown side should be equal to square of these, right? You can always expand and simplify as we did earlier, right? In the previous page, we get this plus 2 x square y square plus y to the power of 4 minus x square minus 2x square, 4, right? X square y square plus y to the power of 4. And from here, you can see all the terms cancel except for 2x square y square, and we do get 4x square y square. And that gives you the unknown as square root of 4x square y square, which is 2xy. So see, we got the value of the one of the legs of the hypotenuse from this strategy. Do you see how we developed it? So now you can say that the three sides are, so we can say one side is 2xy, the other one is x square plus minus y square, and the hypotenuse is x square plus y square. Slight modification of what we know can lead us to such an important thing. Now, there are definitely some restrictions here, which is to say that because there's x square minus y square, and the side cannot be 0, right? So we are taking x to be greater than y, and x is not equal to y. Now, how does this formula work? I would like you to make a table of values, putting different values for x and y, and check for yourself. Do you get the Pythagorean triples? Hmm? Check it for yourself. Say x equals to 2, right? And y equals to 1. Very simple. So if you plug in x equals to 2 and y equals to 1, 2xy will give you what? Will give you 4, right? And if you plug in 2 square minus 1 square, you get 4 minus 1, which is 3. And 2 square plus 1 square is 5. So you do get a triple, which is 3, 4, 5. Do you get the idea, right? So that is how we can actually derive the formula. Many things which look simple and we take it for granted, we might have to look into them in much deeper sense to understand how do we develop from here to the next level, right? So next level, I hope for this should be working on this set. So once you've understood this strategy, take this problem as a challenge question for yourself and try to derive a formula for these kinds of things where four terms are related, right? 3 square plus 4 square plus 12 square is equals to 13 square. And likewise, we can make a series in this particular fashion. So I hope that will give you some curiosity to explore and technical skills to get to the result. Feel free to write your comment, share your views. If you like and subscribe to my videos, it'd be great. Thanks for your valuable time and all the best.